Alright, hello from Romania with love. What I have here, I prepared the necessary components for making all 16 LED display. I chose the LEDs, very vintage ones that I have them for a very long time. I wanted to use the green ones, but they need a little bit more kick in the butt, and these yellow ones are the same old as the green ones, but they light a little bit better. And this I will talk about that in a second. What now? These are transistors, very weird and special transistor. That is letter G or G. Letter. This is letter G. This is letter V. I don't know, probably voltage. I don't know. This is again letter G. G. This is B. So yeah, these are definitely Russian transistors, very old and very vintage transistors that I have them for a very long time. I scrapped them when I was a kid or adolescent probably, and I keep them and I never ever use them because I've always liked these other ones that are a bit more smaller, and these were too wide and too much space occupying. So my priority was to use the smallest ones. That's why this is the circuit for this for only one module here. It is very generalized because these are the diodes actually, and it can be various ways of catching this diodes here. 3 of them, 2 and 2, the other 3 and only 1, and so on. You know, all 4. You know, and I'm only catching the margin, the top and the bottom. I'm catching. I'm soldering, and then I will glue all 4 together between them, and this on the extremities will hold the ones in the middle. That's the idea. This is a scale 1 to 1. Actually, these are the real the sizes of the components, and I took some. I put some tolerances here. I also leave some tolerances for better design. You know, you always leave tolerances when you design such stuff. I'm also having very different resistors. By the way, everything that you have here, probably excepting the LEDs, the LEDs are brand new but very old. But everything that you see here, everything is scrapped. With this project, I'm happy to use all the scrapped components that I have. That's why I don't have the same resistor size, but the same value. They are the same value all. So these are the 10 kilo ones, and these are the 1 kilo ones. But they are greatly, they have some differences between them. But the majority, the large majority is kind of the same. I have some very, very bad resistors, probably made in Romania. Bad resistors in the sense that the link between the leg and the body of the resistor is extremely fragile to overheating and to bending. So if you bend them too close to the body of the resistor, it will snap and the leg will come off extremely quickly. You don't have to bend them too much, and they will. And also the overheating as well. If you overheat too close to the body of the component, it will snap off the leg, and that's it. you will have to find another one. So these are a challenge in themselves, but I wanted to use them for a very long time. These are actually very good. These are but very weird shape. That's the problem, and I don't like them because they are so long. And yeah, pretty much this is it about those. And extremely different diodes between them. If I'm using my metallic tweezer here, it will magnetize, and I don't want. I want to use the plastic ones. So these are very weird diodes. I never seen such diodes before. They have a mark there, and that mark is not the minus, unfortunately. That mark is the plus. I've also tested every diode for connectivity and for short circuit, of course, and every diode is okay, is good. And these ones are, and I have some very strange ones that I scrapped, and I never see them commercially. What I mean, you know. And also, I don't know. Some of them they may have some very interesting properties, but they are. I have a few of them, you know, 1 or 2 or a couple of them, and in small, very very small quantity because they are scrapped, and I will use them. Whatever the technology they involved in them, whatever their role, their significance, I bet there are some very special ones. That's my point. But I don't know what is that speciality of them. So I will use them as regular simple diodes, and that's it. You know, I will be stupid from this point of view, but they occupy a lot of space there, and but I wanted to show you. These are very weird. That sign, that blue sign that you see there. Let me actually zoom in. You see, it's having a blue sign there. That is actually the plus, the positive. Come on, get over. No? Like that. You see, and that's the only sign. And so you pretty much put the positive here and the negative on the other side. And it is a bit hard to work with such diode marking because I'm used the marking to be on the minus and not on the plus. I hope I will not make mistakes with them. I was also thinking to remark them, to make something somewhere and to mark them negative, to make them from positive to negative, the normal way of marking, you know, that I'm at least that I'm used to. There is no normal. So this is it about, there are 16 groups of 4. So 1, 2, 3, 4, 1, 2, 3, 4, and there are 16 groups. Here 16, here 16, 8 and 8, and also 16 transistors. I didn't have another one like this, and I will use another weird one. Also, is having a green dot and another green dot here. It's very, and also no, absolutely no markings. Is absolutely not having any marking anywhere. Only these dots, color dots. And of course I tested everything, and with my transistor tester, which is that one. Pretty much, and like I said, this is 1-to-1 scale, and I made my plans how they will look. They will be this big probably, all the boards together, all the 16 boards together, and then the bus wires. The bus wires is a problem because I have positive, which is common to every board, negative here on the other side, and also the 4 bus wires that are the logic wires, you know, these wires, and shit. Yeah, I have 6 wires, very long wires actually, to drag them and to link everything. And how I will link them, I have no idea yet. I have an idea. I have a plan. I will put this board, this one of these boards, I will put them vertically like this, and the bus wire will be like this. So let me show you like this, you know, vertically, and the bus wire will be also vertically like this on a side, and underneath here it will have the minus wire, the common wire, and here it will have all the 5 on this board, and it will be like a case. On the top, on the other side, it will not have anything, just protection or casing, you know. But on the left and on the bottom, we'll have special boards with all the bus wires and only one here. Pretty much, that's the plan. That's how I imagine it, and that's how I will do it. What I don't like is that this at current scale, at this scale that I have right now, these links, all these links are very close together. For comparison, see my finger here, you see, they are quite close, and I don't like that. I want more distance between them, and I don't know how I will manage it, but I will find a way. I must find a way. Yes, this is the plan. This is the preparation. This is how I prepare before starting anything. Yeah, we'll see what it will come out of it. It's looking very retro, that's for sure. Very, very, very retro, because the components are very retro, including the LEDs. This is it. Thank you very much for this part, watching this part, and we'll see you in the next part, hopefully, when I will start building something. Check this out. Check this out. I have my glue here, which is a silicone glue, based on silicone. And when I squeeze the trigger here, it creates a bubble that remained a bubble. I don't know how clearly you can see it, but it's very interesting. Yeah? A fucking bubble that doesn't blow up. Yeah? Okay. No, it's not focusing on it. It's having too many interesting stuff around. Yeah, this is it. And it's also having, this bubble is having a rainbow on it. You see it? I'm rotating it. Yeah, it's also very, very strange shaped. The bubble. Let's see how it breaks if I'm pressing. Let's see if it's getting bigger or is breaking. I think it will break. Yeah, I can see the fluid coming. Yeah, no, but it's nice. I'm preparing, by the way, to start making the board. Voila, we have a winner. That guy there. When that and that is number 1. It's actually saying on it. I write it on it. I cannot bend it because it will get out of the from the connections, from the soldering. But the connections are in the beginning here. Before, so my board there is in parallel with what I have here, so the current is going through both of them in the same time, in parallel mode, and it is indeed counting to 1, as you can see here, 15, and this is 1. All right. So my board that I have here is a bit more bigger than one module that I have here, but it's okay. It's a retro. It's very retro, and yeah. Look on the wires that I put there. Where is my trusty knife? Here. Do you see those wires? That very thin wire there, another very thin wire there. Also here, between this pin and that ground, and yeah, 3 wires. But this was very weird components I had to put on it. And yeah, it's doing its job. Pretty good. Also those diodes, see how cute they look there? Yeah, they started to bend under pressure. I hope they are not touching. But yeah, it's very promising. Those black dots there, those are the diodes. And I put them with the face down, with the marking down. And they are looking black from this point of view, from this side. And not to screw up my usual reading, I also marked on the cardboard there, the direction of the diode that it should take, and it's exactly as it should be, and it's working exactly as it should be. Let me, like that, and 0, and this is 1, 2, and 3, and it's not lighting until it's time, you know. It's counting all up to the 15 here, When it's time, now 0, now 1. Now both of them. Absolutely fantastic. I love it. I don't like it because it's even bigger than this, but it's good enough. Like I said, retro. All right, see you later, alligator. All right, this is after the test that I did. After I tested this board, I just show you in some seconds ago. I wanted to film it as it is naked, without the wires, and also some close-ups. As you can see, the colored dot is on the plus, and those are yellow dots. But the majority, I only had 3 yellow dots, but the majority are with blue, and that represent the plus. And yeah, they are totally inversed than the usual, but they are looking quite nice, Let me actually hold it in my hand like this, and see how small everything. Well, small, how big everything is. And yeah, it's exactly like I did there. This is negative here. Let me put it there. This is negative. This pin here from the resistor here is the positive, and the rest of the diodes, inputs, pretty much. And they must have a certain direction, for a certain direction combination. And these 3 are linked together this time for number 1, and pointing that direction towards the board. And only the first one here is pointing like this, away from the board, as you can see there. I put a little diode mark, the correct one, because these are they are bugging me. Also, this resistor is not is a special one. It's like a SMD, but it's not. It's a bigger version of an SMD probably, and but it is looking like exactly like a SMD. That was having the pin cut very short to the. So I totally used scrapped, but the rest are okay, scrapped components. But the rest are okay. They have all the legs. I had a few of them that I could very weird, and I hoped I can repurpose them. And this is what I just did here. Except in the LED that is brand new, everything is scrapped and repurposed, which is what I love. It's one pleasure of mine to repurpose into something else, And this is only the first. I have to make 16 of them. All these components that you are seeing here. Shit. Caramba. Here I have some glue to glue some components there. The pads, actually. I'm gluing the pads on which the components are soldered. And this is a silicone. So search for silicone-based glue. This is the glue that I'm using. In this case, it's called Silly Pitch, but doesn't matter what its name. What it matters is this part. Clear silicone glue. It doesn't matter if it's clear or not. It matters if it's a silicone-based glue. So a glue based on silicone, pretty much. And I didn't bought this syringe. I actually transferred from the original tube. And this is the label from that tube. I put it on the syringe. How many milliliters? It's having 20 milliliters. This syringe, this specific syringe. So yeah, pretty much. You see, it's getting yellow because it stayed a very long time. But usually it's very clear. It's very. It's having no color. But in my case, it's having like 1 year or more than 1 year. Then it's staying here. But for 0 and 16, because they are the same thing. Actually, when it's reaching 16, is actually resetting to 0, and that's it. And they are linked together. So probably only one board I will make, the 0 one. So yeah. 15 more. Holy shit. A lot of work. Thank you very much. Oh. I reached this stage when I made 4 boards, and now I'm thinking, how the hell do I make the connections to the bus wires? Because why is such a problem? And you will agree with me in a second. These 4 diodes here, they have different positions of these input legs. And these input legs that for the board, they must link to one of these 4 wires here, 1, 2, 3, 4. So this leg can link to this, and this 3 to the other 3. So it's like a cross like that, or 1 and 2 to the first, 1 to 2 like an X, and this 2 as well as an X, or whatever. This 2 in the middle like an X, and this 2 in the margins like an X. Is not that case for everything, but there are some exceptions when I will have to cross one with the others, pretty much, or at least another one. And that's a very big problem from a mechanical point of view. I mean, how the hell should I make it? My idea is to insert isolator, like a little tube. I have these isolators already from some diodes, bigger diodes, with bigger holes in them, as you can see, and they will play back and forth on these very tiny legs, and but they will assure isolation. But also they will be extremely thick, and the next wire will have to jump this thickness to the corresponding connection there. And then this is really wow. I just stopped, and I'm concentrated exclusively on this problem here because it is a very big problem. And also the connections between the boards, the actual bus wires like this, the 4 bus wires, that all these 4, actually 5. They will be 5 wires because I will have to include this common positive and also a common negative. But this is on another board, a horizontal board, and this will be a vertical board and lateral from a side board. That's my idea to make like this, and these guys will stay like this, you know, and of course vertical like that, and with like this, exactly like this, and a vertical board like that. Of course, I will have to cut the cardboard there to make them exactly like this one as length. And I'm and that's the idea that I come with. But another problem is the length is more. I've added a bit more length to the board, and I really didn't want that. Originally I was planning to link the pins of the legs of the diodes directly to the bus wire, but it is extremely hard to both link to the corresponding wire, like crisscrossing like that, and also link the solder the leg to the correct bus wire. And it's a very difficult part of this project. I didn't expect to be like this hard, and I also didn't think about it too much. But now when I am at it, first of all, I want to make it shorter, and second, to also make it easier for these legs to be connected there. I don't know what I will do. Yeah, we'll see later. All right, back to the bus problem. I made a fate jump in fate, and I want to believe it will be okay. I cut every board back to the minimum as minimum safety, also showing the marking of the diodes there. I could have cut it even more than that, but yeah, I'm always, I learned my lesson many times actually. Always leave tolerances in everything. Once you cut, goodbye. You cannot put it back, and you have to change everything. Leave tolerances all the time, and this is what I'm doing here with these markings that I made there, and I want to believe it will be okay like that. My idea is this will be the board for the cardboard for the bus wire, and it will be vertical like I said. And I actually look on many ways of how to make this bus wires, how to make them. And I had those other pins those are legs, cut legs from other components. I think they were resistors, very thick and from very old components actually, very good to solder on them and with them. Then I have this repairment copper, it's for repair, and I only have this 4 millimeters or 5 millimeters. Yeah, it's 5, right? I'm reading inverse. It's 5 millimeter, and I'm cutting along. So along of it, I'm cutting it like you are seeing. This is 2 millimeter here, cut from this, and 2 millimeter is too much for a single bus wire. And then I have, there you can see, not that much, but I have some. This is the thickest. Those are very thin that I have there left, but this is the thicker that I have. Copper wire, enameled copper wire, and these are scrapped from burned transformers, motors, whatever. I didn't scrap them. Someone else scrapped them, and he gave them to me along with good wires. They were messed up, and I made the difference, which is good and which is bad. Probably that guy didn't know what is good, what wire is the good wire, and what wire is the bad wire. The good wire is having enameled that is colored, slightly colored, even in color. Even without any color, that is the best enamel. Usually they add a little bit of color, or time will add color on the enamel, in the sense that every plastic material, polyethylene something, I am not a good chemist, pretty much something that is made from plastic, is getting a patina in time, a yellowish tint, and is becoming more yellow with time. Even paper, even pretty much everything, from the dust in the air. The dust in the air is affecting the surface, and even enters inside the material. And also ultraviolet from the sun, that is also affecting the color of the materials. And this is the difference. Usually the enamel of the wire, of the copper wire, is either transparent or white-ish, or yellowish, or even sometimes I've seen brand new red-ish. But red-ish or red, yellowish, orange, red-ish, more orange towards the red. But that is a color that is determined, that is telling me, at least from my experience, is telling me those wires, that color of the enamel wire is that the wire was hit up to a certain degree, and the enamel got that color because of the heat of the wire. And these black wires that you are seeing here, as you can guess, it actually is a blackish reddish wire, very black red, and these are burned. It's that simple. The enamel of the wire is telling you the health of the enamel, of the isolator, pretty much, of the wire. So this I can scribble with my finger. So I can do this. Let me find a way aside that I can, and I can show you you see this little point here, and even that. You see that little bit of enamel? That is actually the enamel that is getting some light on it, and it's extremely crackable. It's cracking extremely fast. So that's the zoom in part. And when you you bite it with your nail and is getting out very easily from only from your nail biting like that or scratching, that is not a good enamel. That is not a good isolation. You should put it away and not use it as wire near other wire like that, because they will make a short and it will fuck up your device or whatever you have there. So that's the theory. So these are burned isolation, and I can scratch them extremely easily. I don't even need my trusty knife here, but I will use it because it will get faster with it. And I will add the tracks here and put it like that. Pretty much that's the idea. And also very, very important, when I get to the last one, so in the beginning on the first one I will put it corner to corner like that, you know, and as you can see there are left some distance there from the legs, and they will catch somewhere there, not in the beginning. But the last one, the last board that I have, if I'm cutting, this is actually the entire dimension of these 4 boards, precisely this from here to here. And this part is I left it, and I will not cut it. I will put the entire length this wire. I actually measured it, and I've also left it's not that straight right now, and I left some ears to bend and to catch into this cardboard. And in this part from here to here, the last board that I have, the pins from it will have space to be soldered here, because if I'm cutting exactly as these 4 boards are, on the last board I will have absolutely nothing to catch on, or I will have to bend them around. It will be a shit. But this way, and also the next board, the next track board like this with bus wires, the next 4 will overlap this, will overlap the other one with a little bit, you know. I mean, this little bit will be overlapped by the other one that will be next, and the other one, another glued, actually glued. And that's the idea, that's the plan. I hope it will work. I kind of risk it here, but you know, I'm doing it. You have to risk it. Holy shit. We'll see. I hope it will be good. So I've catched the first one. I made some holes with this pin that I have here, that I made this plastic part around it. It was a needle, sewing needle, that it not cracked, but the sewing where you put the wire cracked and fell off. So I made this plastic and like a puncher, and I'm punching this cardboard with it, and the diameter of the needle will enlarge the hole enough to good enough, you know, good enough, and then I can put the wire, and the wire is simply, as you can see, this is from a chocolate cardboard, and this is how I put the wire. I bend it around, and then I squeezed with this device, with this tool. With this I'm cutting the wire, but with this I'm pressing, and after I'm pressing it good enough, is not moving, even if it's catched on that extremely fragile, you can see, extremely fragile border there, you know, and especially in this corner, it will rupture extremely easy from there, because this is paper after all, you know, it's a cardboard. But if I'm not fucking around too much there, it's good enough, you know. And if I'm not stressing those points, it will be good enough. One more thing I want to show you is how I'm measuring. Let me actually put my I'll put the camera on top here. 1 second. Actually, I can show you. I have 2 sticks and I'm putting the camera there. So this is how I'm measuring and cutting the same length of wire. So when I cut this wire, I made these marks here from here to here, and this is how I'm always getting the same length for all the wires that I need to have the same length, you know. And let me do it the other way, like this. It's not that critical right now. I'm holding it like this for you to see, and hold it because it will jump. And yeah. Oh fuck! I cut the no, that's not good, motherfucker. And we have to get rid of fucked up markings here. So this is from here to here. Fucker. I cut the wrong length. Yeah, shit happens, right? Shit happens. So I'm straightening because it's coming from this round thing. And voila. Right now I'm putting it in the right size. And you see, and there I have the ears to bend, while this one I don't have any ears to bend, and is a waste. But it's not a waste. I will use it for something else. I have some spare wires here, copper wires. This is it. This is what I want to show you. I want to show you how to cut a length of wire, always the same length. All right. All the 4 wires are inserted. I made, as you can see, the chocolate. As you can see, all the bands are parallel with each other, not one like that, you know. And I made a mistake. I put the holes, especially here between these two, extremely close together. Very bad mistake. I didn't. I made it by the eye. I didn't measure anything, you know. And yeah, I thought they are. Yeah, but yeah, I don't like this part here. Yeah, we will see. Now I will have to desisolate these wires with my trusty knife here that I recently sharpened. So voila, the bus wire plus the positive wire that is on top. But the bus wire is cleaned from the enamel, from the isolator on it, and it's good to go. Hopefully it will work. And voila, all 4 of them I soldered all on the bus wires. And like I said, that's why I'm making this segment of the movie. When I have to intersect the wires, I put this little tube, isolation tube here. This is on number 4, and here the second board. So this is 1, this is 2. The second is also having a tube, a black tube. You can see it there. I don't know how to show you. Better say it because this is not staying right. So there it is. You see it? There. From here to here. This is the tube, and it's going to, I believe, the first 1 to 2, while here is going from 1 to 3, and this is going to 1. This is to 2, 4 to 4, and 1 to 3. Yeah, that's the problem. But I kind of make it work. Of course, I will have to bend it, and by bending, I will stress the welding, the soldering, and also I will stress the wires themselves, because if I'm bending them too much, they will break, and I don't want that. But yeah, for the first, for the prototype that I have right here, because this is a prototype after all, I will do it. Do you know what is the first thing that I said when I finished this board, this component, or whatever it is, this section, this module? I said, holy shit. Holy shit, this was hard. Especially the pins, the legs of the diodes here. I'm operating with one hand and I'm a bit flimsy. Yeah, it's staying like this, very good. So here, when I had to cross those legs, some other legs were bending like this, like a letter C, you know, and that letter C was actually making short with the third one here, and they made like that, you know, from being straight, like, and yeah, I had to pay attention to this little fucked up detail, because it will fuck up my entire project. That kind of bending, and I was aware of it. I was keeping it in mind. I hope nothing else is bent and touching anything. Yeah, it's not looking perfect, but keep in mind that all this thing that I'm making here is made on fucking cardboard, and with glue pads, and yeah, with very vintage components. But specifically, this is made on cardboard, as usually I'm making stuff, because I want to prove a point. The point is, if you really want it, you can do it, and that's my point. I hope it's a good point for others. You know, doesn't matter what you're doing in life. If you really want it, you will get it. There are some exceptions, like women's, money, and cars, unfortunately, but and houses. But for small stuff, if you really want it, you can do it. All right, this is it for this part. And this is working absolutely phenomenally well. Absolutely no problem, no problemos. And it is in parallel with the red ones, actually. But the 4 wires that I'm dragging from this module are on these bus wires, directly on this my breadboard bus wires. As you can see there, it says 1A, 2B, 3C, and 4D, and these are actually the bus wires on the breadboard. And I put them there, plus and minus, for the entire board module. And this is 1, 2, 3, and 4, and it's counting exactly in parallel with those red LEDs. I cannot. Yeah, you can kind of see them all in the same time, and absolutely brilliant. I love it. I love it. I love it. This proves something. That it is possible, and it will work towards 16. Oh yeah. Holy shit. This was hard. Especially the bus wire. That was mind bending. It was really mind bending how I'm keeping everything there. It's pretty stable as it is. Yeah. Thank you very much.